It all starts with an idea.
This is Don from Detecting Doodads. What we have here is a Stirling engine. Dr. Robert Stirling invented this technology in the 1800s. It's often referred to as a hot air engine. It's pretty cool technology. There's a lot of people that are experimenting with them again as a environmentally friendly way of producing energy. I've been tinkering with this technology for probably a decade on and off. Combining 3D printing, I'm into the kinetics and how can we display things in a unique way. I think this is going to be pretty cool. I'm going to do a test run here. This is a gearbox I printed up. This engine ought to run around 800 RPMs. It's a walking beam engine. So you have sealed air in this glass cylinder. You have a piston that moves the hot air out into the power displacer, which cools the air, and it's just a heating and cooling cycle rapidly taking place. I have a little candle here. This one's burning just lantern fuel, but you can run it off a little teacup candle, whatever. So at 800 RPM, my goal is to rotate a Relic, say a belt plate or something. This is spinning about 800 RPM. I want to be able to spin the Relic at around 2 to 6 RPM. So I designed this gearbox. We'll take the 800 RPM and reduce it 240 times. So the end, you can see how fast I'm spinning this, and then this gear is barely moving. This is just prototype. I have no bearings. It's just sitting on a screw. So the problem with Stirling engines, they don't put out a lot of power. This one may put out about 3 watts. So even though it'd be spinning very fast, there's not much horsepower there to turn all these gears. So this is just an experiment. The final gearbox would have bearings to reduce the friction and make the thing more efficient. These are just spur gears, driving pinion gears over and over again, and then I came out with a little right angle bevel gear here, come up and do something with it. So it's just ending here for now. But I just want to see if this has enough oomph to drive these gears. So to light it, you just light the little candle here. So we're going to put it on the flame onto the glass cylinder and let it heat up for a little bit. I got a piece of reflective tape here, and what I'm going to do is shoot it to get the RPM. They're pretty cool. It takes about 30 seconds to a minute to heat up. It's cold and raining today, so it's maybe take a little longer. Once that glass heats up, that air is inside the cylinder, and when this flywheel turns, I'm going to start it by turning it counterclockwise here. Just let it heat up a little bit. She's started. And it'll just continue to run. Should be speeding up here as it warms up. So that's it. Walking beam Stirling engine. Let's see what we got here. About 800 RPM. Yep, pretty good test. Now all this noise, I have bearings on this vertical rod that are loose. One of the things about the Sterling engine where they're whisper quiet, this one's quite loud. Noise is inefficiency, so I'm going to do some work in the linkages to get it running right. I have a heat source here, but you'll see as I take it off, it'll run quite a while. Not much heat coming off of it. Yep, he's running pretty good. All that coming from there.
I'm giving her all she's got, Captain. If I push it any harder, the whole thing will blow.
All of that. And that tiny spring.